So here, when we factor completely, we got to go back to our a cubed minus b cubed formulas. A minus b, a squared plus ab plus b squared. My a cubed here is 27x cubed. So my b cubed is 64. We don't worry about the sign with that. Therefore, a is 3x and b equals 4. And I'm literally just plugging in. 3x minus 4, 9x squared plus 12x plus 16. That's what I get when I plug the 3x and the 4 in for the a and b. My second problem with the 4 terms there, we're factoring that by grouping. I put parentheses around the first 2 terms. We put a plus sign, and we take that middle term and put it with, or that middle sign, put it with the third term. My GCF of the first one is 4x squared. We're left with x minus 3. We pull a negative 2 out. We're left with x minus 3. 4x squared minus 2, x minus 3. Now I got to factor this completely. If this were a difference of 2 squares, you'd have to factor it. It's not. But I can take a GCF out of here. And now I'm left with 2 times 2x squared minus 1, x minus 3. And that's this problem factored completely. You don't need to set them equal to 0 because it's just saying factor. And they're not equal to anything. So there's nothing to solve. We're just factor. So I'm going to take 4x cubed minus 7x squared plus negative 16x plus 28 equals 0. We take a GCF out. It's x squared, and we're left with 4x minus 7. We take a GCF out. It's negative 4, and we're left with 4x minus 7. So now, x squared minus 4, 4x minus 7. We want to factor completely. So it's x minus 2, x plus 2, 4x minus 7. And we set each parenthesis equal to 0. X equals 2. X equals a negative 2. 4x equals 7. X equals 7/4. And that's your answer. You always factor as much as you can. Here I'm factoring normally, only it's going to be an x to the 4th. 2x squared and x squared. My factors of 35 are 7 and 5. 7, 5. We have a negative here, we have a positive here. And we're setting each parenthesis equal to 0. 2x squared equals a negative 5. X squared equals a negative 5 halves. Now, when you take the square root of both sides, you're getting plus or minus I root 5 over root 2, which means you need to rationalize root 2 over root 2. My answer is plus or minus I root 10 over 2. Second one's a little easier to work with. X squared minus 7 equals 0. X squared equals 7. X equals plus or minus root 7. And those are your answers. Okay? So in this case, this is going to be x squared minus 36. X squared plus 1. You can't factor a sum of 2 squares. We just leave that. But this can be factored. The difference of 2 squares can be factored. X minus 6 equals 0. X equals 6. X plus 6 equals 0. X equals a negative 6. X squared plus 1 equals 0. X squared equals a negative 1. When you take the square root of both sides, the square root of 1 is 1. Since it's a negative 1, it's the square root of plus or minus I. With x to the 8th, x to the 4th minus 16, x to the 4th minus 9. These are differences of two squares. We can factor them more. X squared minus 4, x squared plus 4. X squared minus 3, x squared plus 3. And we have one more difference of two squares. X minus 2, x plus 2. X squared plus 4, x squared minus 3, x squared plus 3. That is completely factored. Anytime you see difference of two squares, you've got to factor a little bit more. And then you're setting each of these equal to 0. X minus 2 equals 0. X equals 2. X plus 2 equals 0. X equals a negative 2. X squared plus 4 equals 0. X squared equals negative 4. My x is plus or minus 2i. X squared minus 3 equals 0. X squared equals 3. Therefore, x is plus or minus root 3. And finally, x squared plus 3 equals 0. X squared equals a negative 3. X equals plus or minus I root 3. And those are our answers. You should get 8 answers. All right. What makes this parenthesis equal to 0? 6. 2, negative 15, 9, and 54. Drop the 2, we get 6 times 2 is, oops. Sorry about that. We drop the 2, 6 times 2 is 12, we get a negative 3. Negative 3 times 6 is negative 18, we get a negative 9. Negative 9 times 6 is a negative 54, we get a 0. So 2x squared minus 3x minus 9. We need to factor that. 2x plus 3, x minus 3, and my other factor is x minus 6. It's literally given to you. If they just ask for the factors, that's your answer. If they ask for the zeros, negative 3 halves, 3, and 6 are your zeros. So this would be the complete answer. Yeah. All right, so on this one here, we're given the factor negative 7 makes that divisor equal to 0. So 3, 16, negative 37, negative 14. We drop the 3, we get negative 21. That's negative 5. We get 35. That gives me a negative 2, and then we get 14. We have 0. When I factor this, 3x squared minus 5x minus 2, it factors to 3x plus 1, x minus 2, and then I include my other factor of plus 7. So my 0 is negative 1/3, 2, and negative 7. Solving for k. Now, when you solve for k, you have to be told that this is going to be a factor. So in this case, we're working backwards a little bit from the answer. If I know something is a factor, that means the remainder has to be 0. Which means this number here has to be negative 15, which means this number here has to be negative 5, because 3 times negative 15 is negative 5. Now I start from the beginning. Drop the 2. 2 times 3 is 6, negative 9. Negative 9 times 3 is negative 27. So essentially, k and negative 27 has to equal negative 5. When I add 27 to both sides, I get 22. And that's my answer. Now, if you want to check your work, feel free to. 3, put the k in and see what happens. You should get back to a 0. 2, we get 6, negative 9, negative 27, negative 5, negative 15, and it's 0. That means this 22 has to be correct. So, because it is a factor, we're allowed to assume that we have to have a remainder of 0, which means this is 56. What times 2 would give me 56? A negative 28. Negative 2 times negative 28 is 56. Now I come down this way. We get negative 2, we get 7. This is a negative 14. K and negative 14 equals a negative 28. So K equals negative 14 when I solve. I would strongly recommend checking work here. Negative 2, 1, 9, negative 14, and negative 56 to see if you get that 0 back. Negative 2, we get 7. Negative 14, I get a negative 28. And that becomes a positive 56, which adds up to 0. 2, negative 1, negative 23, 4, and 60. There's nothing to guess. Drop the 2. We get 2 times 2 is 4. 3 times 2 is 6. Negative 17. Negative 34, we get a negative 30. Negative 60, we get a 0. Now let's put 3 in the box. 2, 3, negative 17, and negative 30. Drop the 2, we get 6. 9 times 3 is 27, we get 10. 10 times 3 is 30. After both synthetic divisions, we can factor. You have to synthetically divide twice, then you can factor. Now remember, when you factor, you can't have a GCF in a parenthesis. It makes no sense to try 2 and then 5. But if I do 5 and then 2, that works. My other given factor is x minus 3, x minus 2. And my zeros, negative 5 has, negative 2, 3, and 2. Those are my answers. Here we put the 1 in, 3, negative 4, negative 37, 14, and 24. Drop the 3. We get a 3. Negative 1 times 1, negative 1, that's a negative 38. Negative 38, we get a negative 24. Negative 24 gives me that remainder of 0. Now plug the negative. Sorry about that. So here, we should have 3, negative 1, negative 38, negative 24. We got to use that depressed equation. Drop the 3, we're at negative 9. It's negative 10. 30, we're at negative 8. And then a positive 24 gets me to my remainder of 0. So from there, 3x squared minus 10x minus 8. 3x plus 2, x minus 4, x minus 1, x plus 3. So we have negative 2/3, 4, 1, and negative 3 is those zeros. There's your answer.